Good evening and welcome to NPTEL classes. I am here to solve chemistry class 12th NCERT problem 2.27. Let me read the problem. If the solubility product of copper sulfide is 6 into 10 raised power minus 16, calculate the maximum molarity of copper sulfide in aqueous solution. Now, going through the problem, I got to know that problem is based on two concepts. Concept one is solubility product, which class 12 students might have read in their class 11th chemical equilibrium chapter, or in fact ionic equilibrium chapter. And next problem is based on concept of molarity, concentration of solution. And in fact molarity is in your class 12th syllabus, that too in second unit, that is solutions. That is why this problem is present in your NCERT exercise, because it relates your 12th class chemistry information with 11th class chemistry information. From here you get to know that chemistry is basically for that matter any science is connected. Chemistry is connected, your chemistry is connected, 11th is connected with 12th, and next chapter is connected with previous chapter. So if you are continue and if you go through all the chapters in your class 11th students, and in your class 11th and in your class 12th, then only you can be able to solve maximum problems in your forthcoming competitive exams. Now problem is based on this solute, copper sulfide. Copper sulfide is sparingly soluble in water, and for any sparingly soluble salt in water, only small amount of it gets dissolved, and rest of it remains undissolved. And a certain stage reaches, during this dissolution process, certain stage reaches where this solution attains state of equilibrium, where rate of dissolution becomes equal to rate of crystallization, and to this solution we name saturated solution. Here at this state of solution, dissolved concentration of salt or solute gets fixed, and it becomes maximum concentration of solute that can be dissolved in this solution at that particular temperature. And concentration of saturated solution is equal to solubility. Since here concentration is expressed in terms of molarity, so molarity of saturated solution, maximum concentration of saturated solution becomes equal to its solubility, or I may say solubility of saturated solution is the maximum concentration that can be dissolved in it at that particular temperature. This is sparingly soluble salt. It will exist in form of ions, that is cupric ion, copper 2 positive, and sulfide ion, that is sulfide 2 negative. And one formula unit of copper sulfide forms one copper ion and one sulfide ion. Because its solution will represent a saturated solution, and maximum concentration of saturated solution becomes equal to solubility. That is why solubility is given from soluble, that is why solubility product is given. From solubility product I can get solubility, and that solubility will become its maximum molarity or maximum concentration, because maximum concentration of saturated solution is its solubility. Now coming first to solubility product, it's if its maximum concentration in solution is equal to solubility, then what will be the, at equilibrium, what will be the concentration of copper ion equal to solubility of the salt, because it is 1:1. What will be the maximum concentration of sulfide, what will be the maximum ionic concentration of sulfide ion equal to concentration of, maximum concentration of copper sulfide, which is equal to its solubility, because solution represents saturated solution S. As stoichiometry was 1:1:1, so is the relation between their maximum concentrations. Maximum concentration of copper sulfide is S, which represents its solubility. Maximum concentration of copper ion in solution will be equal to solubility of copper sulfide. Maximum concentration of sulfide ion will be equal to solubility of this copper sulfide. Now solubility, this is AB type of salt. Copper sulfide is AB type of salt. AB type of salt. AB type of salt. And for AB type of salt, solubility product is related with solubility. Solubility product is represented by KSP. Solubility product is related with solubility by this expression. KSP is equal to solubility square. KSP is equal to solubility square. KSP is the solubility product, that is maximum product of ionic concentrations of copper ion and sulfide ion. Let me show you how it comes. KSP, K is equal to, equilibrium constant is equal to concentration of copper ion at equilibrium, fixed concentration of copper ion at equilibrium, fixed concentration of sulfide ion at equilibrium, raised to powers which are their stoichiometric coefficients, that is 1:1, concentration of copper sulfide at equilibrium, raised to its stoichiometric coefficient, which is 1. Now because it is sparingly soluble, maximum amount of will remain undissolved, so this I can take equal to constant, and constant multiplied by constant will become one more constant, which we name as solubility product. So solubility product will be equal to concentration product of maximum ionic concentration of copper ion, maximum dissolved concentration of copper ion, and maximum dissolved concentration of sulfide ion. And what is concentration? Maximum dissolved concentration of copper ion and sulfide ion at equilibrium equal to solubility maximum concentration of copper sulfide. Maximum dissolved concentration of copper sulfide, that too is equal to its solubility. Therefore I can write KSP, solubility product, is equal to what I should write instead of maximum concentration of copper ion, its solubility of copper sulfide, S. What should I write instead of maximum concentration of sulfide ion? Solubility, that is S. So solubility product for AB type of salt, for copper sulfide, solubility product and solubility are related by this equation. Solubility product is square of solubility. From this equation, this is what I said in the start, that first part, this problem is based on two concepts, first solubility product and then concentration. Now what I can get from solubility product? From solubility product I can get solubility first. Now let me calculate solubility. Solubility will be equal to and square root of solubility product, square root of solubility product. And what is square root of solubility product? Solubility product is 6 into 10 to the power 16. I need to calculate square root of this in order to get solubility. Square root of 10 raised to the power minus 16 will be 10 raised to the power minus 8, and square root of 6, I don't remember square root of 6 exactly. Square root of 4 is 2. Square root of 9 is 3. So it will come between 2 and 3. Let me write 2.5. Solubility is equal to 2.5 into 10 raised to the power minus 8. 10 raised to the power minus 8. But question says calculate the maximum molarity. Calculate the maximum molarity of copper sulfide in aqueous solution. Now, when can we calculate maximum molarity from solubility? It is only possible when solution is saturated. When solution is saturated. Idea is this important. This problem is basically based on this idea. This is the heart of this problem. When solution is saturated, solubility is equal to its maximum concentration. Solubility is equal to its maximum concentration. Now I needed to calculate maximum molarity. So maximum molarity will be equal to solubility because solution is saturated, and it is equal to 2.5 into 10 raised to the power minus 8. Because it is molarity, unit will be mole per liter. I am not sure whether under root of 6 is 2.5 or less than that or greater than that. Please check that. Otherwise, rest is correct. And as already said, that heart of this problem is this. When solution is saturated, we can only solve this problem when we have two ideas in mind. First, so what is the relation between solubility product and solubility for salt of AB type, for example copper sulfide. Second, and how we can get maximum concentration from calculated value of solubility. And second idea is if solution is saturated, solubility represents its maximum molarity. Solubility I got 2.5 into 10 raised to the power minus 8, so maximum molarity will be 2.5 into 10 raised to the power minus 8. Class 12 students, be blessed, take good care of your health and then of your studies. Stay aligned with your teachers in your respective coaching institutes or educational institutes. See you day after tomorrow, because tomorrow is turn of class 11th students. Allah Hafiz.